Origins of Unfairness book, though it doesn't directly address the sort of models that Cailin was talking about earlier, where you have social groups evolving different conventions that can be better or worse for them. But I think at the end, it will become a little bit clear how a project like this could come out of that project and what the connection was. All right, so it's a talk about conventions. Here's one example of a sort of classic convention in human society. So in some societies, people drive on the right-hand side of the road. In others, they drive on the left. This is an example of conventions. There are many other types of examples. We have different conventional greetings. In some places we shake hands, in others we bow, in others we kiss on the cheek. There are conventions surrounding gender division of labor in almost every society. I mean, we can come up with hundreds of examples. But what is a convention? Well, this is something philosophers argue about, unsurprisingly, but it is generally agreed that conventions involve stable, sometimes beneficial patterns of social behavior. And then a key part of the definition is that these behaviors are arbitrary in the sense that they could have been otherwise. So the sort of big picture aim of this talk is going to be to argue for a conception of conventions as coming in degrees of arbitrariness. So usually when people have talked about them in the past, they talk about things as either being a convention or not, and I don't think that's the right picture. And then second, to give a measure that will be able to put a number on how arbitrary different conventions are. And at least part of the aim here is to improve cultural evolutionary explanation. So when we talk about different cultural traits that emerge, I don't think it makes sense to explain them either as entirely functional or entirely arbitrary, but usually they are both to differing degrees. And that'll be something that hopefully improves how we address explanations of traits in some cases. Okay, so here's a roadmap for the rest of the talk. So first, I'll talk about some philosophical accounts of convention, including some that do think about conventions as coming in degrees of arbitrariness. Then in the second part, I'll talk about evolutionary models of cultural traits in order to sort of set us up for the rest of the talk and the measure. Then I'll introduce this measure that I'm outlining here. And then in part 4, so I won't have enough time to really get into this part of the talk. In the paper, I apply the measure to a number of different cases, but I'll just sort of quickly mention one case related to gender division of labor and the emergence of these kind of set patterns of gender division of labor. Okay, so part 1. So David Lewis is the philosopher whose account of convention is still really the received view. It's still the one people start with or respond to. So he wrote this book in 1970, where he describes conventions as being a kind of equilibrium in a coordination game. So here is an illustration of a coordination game. It's supposed to be a representation of a scenario where you have, individuals interacting. They want to coordinate their behavior, and there are multiple ways for them to do it. So this is, in some ways, the most simple one you could imagine. You have 2 players, player 1 and player 2. There's 2 different things they could do. They could pick option A or option B. And here in this table, we see their payoffs for their different selections, with player 1 listed first. And if they both pick A, they both get a payoff. If they both pick B, they get a payoff. But if they miscoordinate by choosing different options, they don't get a payoff. So this represents something like this driving scenario where A could be the right side of the road and B could be the left side. And they don't care very much which side they drive on. They just care that they drive on the same side of the road so that they don't crash. So in thinking about conventions, Lewis gives a kind of precise definition, but approximately the idea is you have a group of individuals, everyone's adhering to one such equilibrium in a coordination game. And they're expecting that everyone else is going to adhere, and they prefer to do it if others do so, and others prefer to do it if they do so. And that is what a convention is for him. All right, so there have been many challenges to this account over time. I'll bring up one from Margaret Gilbert, which will be kind of relevant to what I'm doing here. So she points out that there are games which are going to fall under Lewis's definition, but where the conventionality of the convention seems attenuated. So for example, here's this same game from Lewis, but we can imagine that now one of these equilibria gets much higher payoffs than the other. So let x equal 100. Now the B equilibrium looks much better from a payoff standpoint. So Gilbert points out if you're looking at a society and everyone's playing B, that seems less like a convention. Instead, you'd be like, well, everyone's picking B because it gets you this better payoff. Now, Lewis actually does have a response to Gilbert, and his response is, this isn't actually the kind of scenario I'm talking about. This is a scenario where A is what he calls a deficient option, and you couldn't actually get common knowledge in a group that everyone's going to intend to play A. So you don't have conventions here. In fact, you only have one option, which is B. But I don't think this response is really adequate because we can imagine a whole range of scenarios from Lewis's example where x equals 1 to Gilbert's example where x equals 100. And it seems weird to say that at some point you go from a case where you have conventions to a case where you don't, rather than saying we have a whole continuum here of examples from ones where the choices really are quite arbitrary to where they're less arbitrary, where there's some reason why you pick one choice or the other. Ruth Millikan has written a lot about convention, and she has been mostly thinking about linguistic examples and especially semantic meaning. And for her, in defining convention, she includes a requirement that convention should be unlikely to emerge a second time. So something like if you roll back the cultural evolutionary tape and start again, you probably will get something else the second time. But if we look at Lewis's key example of convention, that's actually a case where if you did this, there's a pretty good chance that the same convention would emerge again. So absent other factors, we might think, well, there's a 50-50 chance you get the same convention again. And here I think we have another scenario where we'd want to sort of think about there being a range of cases between the kind that Lewis is thinking about, where there's arbitrariness between some choices, but just a small number of choices, and the cases Millikan is thinking about, where there's a huge number of choices. And we might again want to say the latter case has more arbitrariness going on there than the former case. All right. So those are some reasons why we might want not to think of conventions as coming in either or, but rather a kind of range of arbitrariness. So there have been a very small number of philosophers who have sort of advocated for this sort of degrees of conventionality idea. One paper that does so is this paper by Mandy Simons and Kevin Zollman. Hi, Kevin. That was just published last year. So they're motivated by cases having to do with linguistic implicature. And what they do is argue that convention should be thought of as more or less natural versus, we might say, arbitrary. And they give a few senses in which conventions could be more or less natural. So their first sense is that some conventions are better than others from a payoff standpoint. So that corresponds to the Gilbert point. Their second sense is that some conventions are more likely than others to emerge. So if we think about a sort of cultural evolutionary process, some things are likely to come out at the end of this process. And then the third sense is that some conventions are more stable than others. If you're at that convention, you're unlikely to abandon it for different reasons. So in this talk, I'm really going to focus on this kind of second sense, the idea that some conventions are more likely to emerge than others, and that's the sense that really tracks for me the notion of arbitrariness people usually have in mind when they're thinking about conventions. Arbitrariness there usually means something like, could it really have been otherwise? So keep that in mind as we go forward. That will be the sort of notion of arbitrariness that I'm trying to measure. Okay, so with that, let's talk about evolutionary models of cultural traits. This will sort of give us a framework to talk about measuring conventionality or arbitrariness of conventions. So cultural evolutionary models generally involve the following things. So usually you have a population with different possible variants or strategies. So in the coordination game example, those strategies could be driving on the left or the right-hand side of the road, A or B in that coordination game. Then you usually have in the model some kind of repeated interactions over time. So some cultural interactions going on. And then third, these models usually have some rules for change called dynamics that stipulate, okay, how are these variants or strategies going to change over time based on the interactions occurring, so some specific rule. So that's what the models usually look like in a sort of general sense. And what usually happens is that these models, they change over time via these dynamics and then end up at equilibria. And equilibria in cultural evolutionary models usually look like stable, possibly beneficial states that typically could have been otherwise. So in other words, a lot of these models provide good representation of the cultural emergence of conventions. So what I'd like to do now is just sort of give an example of a model to ground our ongoing conversation here. So let's consider a population playing this game. It's the basic coordination game from Lewis, and evolving according to a standard dynamics. I'm not going to say a specific one, but let's say it's of the class of dynamics that are very often used, where strategies that get better payoffs tend to spread according to how much better they are, and strategies that get worse payoffs tend to die off according to how much worse they are. So this could represent a situation where you have a group of people engaged in some interaction where they're learning to coordinate, and maybe they imitate the strategies that do really well, or they repeat the strategies for themselves that do really well. So what happens in this kind of model? We can represent these outcomes using what's called a phase diagram. So here's a phase diagram for this model when x equals 1, when we have two equilibria that yield equally good payoffs. So what this represents is, for a group of people, all the possible states of strategies they could play, from everyone driving on the right-hand side of the road to everyone driving on the left-hand side of the road, and all the sort of states in between. And what we see here is represented by these arrows, that when you're in a situation where there are more people playing B, the population moves towards even more people playing B. And when people are playing A, more people are playing A, you move towards even more people playing A. And this should make sense in a coordination scenario. If there are more people playing B, well, then they tend to coordinate more on B and they get higher payoffs. And then that ends up being where the population goes. And ditto with A. Now, here's the kind of same model, but where x equals 50, where you have one equilibrium that gets a much higher payoff. And you can see the qualitative behavior is similar here, that when you're very close to B, you move towards all B, and when you're close to A, you move towards all A. But for this situation, there are many more population states that are going to end up at the B equilibrium, at this better equilibrium. And the reason is that even if just a few people are playing B and they're managing to coordinate, well, it gives such better payoffs that it does better than A. And so you expect people to start imitating that behavior and maybe learn to go to this higher payoff equilibrium. Okay, so that's what these models look like. We can define for them what are called basins of attraction. So a basin of attraction in this kind of model is the set of states that goes to any particular equilibria. And we can see for this Lewis coordination game, where the equilibria are the same, these basins of attraction are equally sized. So absent other information, we might say, well, it's just as likely you end up driving on the right or the left-hand side of the road. In a scenario like the second one, the basin of attraction for the B equilibrium, the better one, is much larger. So absent other information, you might say it's more likely we end up at this equilibrium that yields these higher payoffs for us. Greater likelihood of emergence. There you go. Okay, so with that, we sort of set up what cultural evolutionary models look like. So now let's develop this measure. Okay, so I'm going to present a measure that's supposed to track the arbitrariness of conventions. and it will draw directly on information theory. So this is the theory which addresses questions related to the transfer of information. And you might ask, well, what is the connection here? So we have different equilibria with different probabilities of emerging in the simple model I introduced. These are the basins of attraction. These probabilities determine how much we learn or how much information we gain when we see what has evolved in some scenario. And that amount of information is going to be our measure. Now, in particular, the measure I'll use is called Shannon Entropy. So in information theory, entropy measures for some channel the expected amount of information on average that will come through it. So a channel here is just a variable that could be in different states. So it could be that you're talking on the phone and each word is a message that comes through. So it's a different state that you could be in every time you say a different word. Or you could have a stoplight that could be green, yellow, or red. So there are three messages there, and that's the channel. And you see which of those states the channel is in. So if we want to say how much information we get through a channel, we basically take a weighted average. So we look at what are all the messages that could come through this channel. We sum over them the probability of that message. So how often do we get that message times the amount of information in it. So how prevalent is this message? How much information does it contain? That's how much information is in the channel on average. Of course, the next question is, well, how much information does each message contain? And the answer is that is determined by how probable it is. And in particular, it is the negative log of its probability, which if you're not familiar with this, you might be like, well, what? Why? What? There are good reasons for this. I'm not going to go through exactly those reasons, but I'll give a kind of intuitive sense of why this is a good way to measure the amount of information in a message. So here is a negative log function. So when x equals 1, if a message is completely certain to come through a channel, then its information content is 0. There's no information in it. And this should make intuitive sense. So imagine we have a stoplight that's always red. You know it's going to be red. You look at it, it's red. You learned nothing new. You're not surprised at all. You didn't gain any information by seeing what state it was in. And then the less probable a message is, the more information it contains. And this again should make some intuitive sense, because if a message is very improbable, it can surprise you. You can learn more when you receive it. So if I said to you, a moose just walked into my room, that statement should contain more information than something like a cat just walked into my room, because the moose statement is more surprising. It tells you more. You might have thought there was a good likelihood cats were already sort of walking around in my room because lots of people have cats. Okay, so let's give a kind of general statement of how entropy works here. So when we hold other aspects fixed, the entropy of a channel is going to be higher when the messages are closer to equiprobable. You learn more when messages are closer to equiprobable, because it's not like one message is just coming through all the time and you expect it and then you see it. And it's going to be higher when there are more messages. And maybe now you're sort of seeing the picture. This equiprobable thing sort of tracks the Gilbert case, and the more messages thing sort of tracks the Millikan case. All right, so let's pull this all together. We can use entropy to measure how surprising it is on average, or how much we learn when we observe a particular convention in a society. So the messages here are the conventional outcomes that could emerge on a cultural evolutionary timescale. They have different probabilities of emerging. And then the higher this entropy is, the more arbitrary some certain arena is, the more things really could have been otherwise. And this tracks both the sense that they could have been otherwise because of payoff differences between equilibria, and the sense that they could have been otherwise because there are more or less equilibria that you could have ended up at. So to return to this sort of simple toy model, in this case, if we calculated the sort of entropy in this system, it would be 1. That's 1 bit. That's the particular unit I'm using there. Whereas in this situation, where it's quite likely that one equilibrium emerges, the entropy is 0.13, so it's much lower. So that means here we learn a lot more, and there really is some sense in which each equilibrium, a stronger sense in which they could have been otherwise, in which they're more arbitrary. All right, so when we apply this measure, we see there's really only one value here, which is 0, where traits are not conventional or arbitrary at all. And these are cases where just one outcome is guaranteed to emerge in a culture. And then for all other situations, there's some chance that things could have been otherwise. Furthermore, there's no end to this measure. Conventions can be arbitrarily arbitrary. You can get, as high as you like when there are really a lot of things that could have emerged. And, say you're looking at like a semantic meaning example, you can have a very, very high arbitrariness. And I think this kind of framework pushes against accounts that want to separate conventions from non-conventions and instead focus in what I think is the interesting place, the sort of diversity within the category of convention. Now, hopefully this also informs how we explain cultural traits. So you often see cultural traits being explained by appeal just to their function or to sort of historical chance factors or just to coordination needs. Instead, almost every trait is somewhere on the scale of conventionality. It's about coordination and it's about function most of the time, at least to some degree. Okay. So I'm getting toward the end here. I want to bring up a couple challenges for the models and then just kind of flag one example of a place where challenges for the framework and then flag one example of a place where I apply it in my work on this. So here's the first challenge. You might say, well, does this only apply to these models? I gave this kind of specific example. And the answer is no. You can apply this basically to any probabilistic representation of the emergence of conventions. So there's many different types of cultural evolutionary models you could apply this measure to. You can also apply it to real data. So you can look at cross-cultural data sets and say, how often have different conventions emerged across different societies? You could look at outcomes of lab experiments where you have small groups of people develop conventions in a lab and say, how often do they develop different conventions in this kind of experimental setup? So it's pretty broadly applicable. Second challenge, and this is like the deepest one, has to do with representation dependence. So of course, if we look at any real case of conventions, there are going to be a lot of ways to represent probabilities that different things might have emerged. We can never observe real probabilities of conventions emerging. Even if we're looking at cross-cultural data, that data is shaped by choices of the researchers and all sorts of historical dependencies between cultures. So basically, there's no way to go about just picking up what these probabilities are from the world. So that's kind of one issue. And then a related issue is that when you're looking at scenarios of conventions emerging, there are often many different things that you might want to measure about the same scenario. So you might want to think about the arbitrariness of a convention absent any kind of context. Or you might want to think about the arbitrariness of a convention given the particular historical and cultural influences that led to that convention in this particular case, right? So it's both that there isn't any sort of objective way to pick up these probabilities, but also there might be different probabilities you'd be interested in, even in the same case. And there isn't some big answer here to solve this, but the best I can say is that, well, representations should be sensitive to the explanatory aims of a project. What are you trying to do or explain when you're looking at a particular cultural trait? Well, you want to build a good model or use a good data set that is sensitive to those aims and recognize it's imperfect or there could have been other ways to do it. Challenge 3 has to do with probabilities. many people think we live in a deterministic world, and on this picture, there isn't any real sense in which a convention could have been otherwise. We all had to be in the situation we're in right now. But I think in this case, recognizing that this is a representation dependent measure actually helps. So what we're doing is representing probabilities that different conventions emerge in whatever way is appropriate, using models, data sets, whatever, and then just going from there. Okay. So in the paper, I apply this measure to a couple different cases. One is gender division of labor, and then 3 of them are linguistic cases. So I'll just kind of flag the gender division of labor case as something relevant to this group and audience. So you can look at cross-cultural data and see that traditional societies divide labor by gender. This is a ubiquitous pattern, but there's a lot of variation in how this is done. And there's also variation from task to task in how arbitrary this division is. So there are some tasks like young infant care that if you look cross-culturally are predominantly performed by women. And that seems to be because in most cultures, most women are female and females have, breast milk. And so there's a sort of functional reason in that case why you see this particular division of labor. And then there are other tasks like big game hunting that tend to be performed by men. But then there are a lot of other tasks like rope making, caring for small animals, carrying burdens that tend to fall to one gender or another, but there isn't a lot of pattern to it. It's much more arbitrary, sort of who ends up doing which jobs. And then there are things that are also kind of in between, most of the time women end up doing it, but sometimes it's men. So you see this whole kind of range of arbitrariness in this particular case. This is actually the example that led to this whole project. You can run the kind of analysis or apply the framework here to models of gender division of labor or data sets and look at the conventionality of these various arenas of division of labor and see that some are more conventional than others, but almost all of them are conventional, at least to some degree. So they'd count as conventions for Lewis. And then once we look sort of within that set of conventions, we can see this kind of range of arbitrariness. And I think this picture is kind of informative to debates over innateness of gender division of labor, over psychological sex differences. And I go into more details about that in the paper. All right, so with that, I'm out of time. I'll just sum up. Conventions come in degrees of arbitrariness. Recognizing this arguably improves cultural evolutionary explanation. 2, we can measure the arbitrariness of conventions using entropy. 3, this measure can be used in arguments about the evolution of conventions, including about gender division of labor and language, though I know I didn't make this point particularly strongly in this version of the talk. And with that, I will say thank you.
Thank you. Oh, that was wonderful. So let's see if there are questions in the chat. If not, if people can raise their hands as long as I see that in the video. I only have 4 pictures, so I'm not sure I'm seeing everyone, but if I can't see you, please. Okay, Jose, please.
Yeah, sorry, I'm not sure whether this is interesting, but I'm kind of puzzled as to why you use the word measurement rather than representation. And the reason I ask this is because from sort of very simple-minded view on measurement, it kind of works because you can look at one thing that you see more clearly and use that to calibrate something else. And I was thinking an example that came up earlier was the convention of admiring ripped jeans. And I was wondering how you would get an independent grip on the entropy and the informational value of discovering that there was a convention of ripped dreams, irrespective of your judgment as to how arbitrary that convention was. It just seems to me that these are you haven't got an independent measure here. So, but you have got a way, perhaps, of you've got a probabilistic model for representing your judgment of arbitrariness.
Well, so to be clear, the measure takes you from some representation of the scenario to a number that tells you how arbitrary it was. So it goes from, these sets of probabilities to some number that tracks how much you learn when you find out, sort of what comes out of this cultural scenario. But I completely agree that the first step is developing some representation of a cultural scenario. And there are often a lot of ways that you could do that in different cases. Now, that doesn't mean there's any way you could do it in any case. So if we think about this ripped jeans scenario, if you want to build a model thinking about, well, how likely was it that ripped jeans become popular? There are different ways that the real world constrains what model you could build of that scenario and what would be a reasonable representation of it. One thing that I think is that this framework, though, does work best in cases where there are some more constrained or set kind of options for cultural outcomes. So something like fashion is very unconstrained. Semantic meaning is very unconstrained. How do you build a model saying how many options there were that we used the word fingers to mean fingers, right? It's almost impossible. It's just there's sort of an indefinite number of possibilities, and fashion, I think, is kind of similar. Examples that do work well. So for example, in the paper, one thing I talk about is word order. So different languages have typical word orders, and that says whether subjects, verbs, or objects come first, second, or third. There's 6 options, and you can look across languages and put them into each of the 6 buckets. So in that case, it's much easier to say what a good representation is going to look like of the kind of evolutionary scenario you're in.
Thanks.
Right. We have a question from David.
Hi, thanks, Cailin. I really like the approach. I guess I have a question. So I hadn't thought about conventionality this way, and it's a very good kind of answer to the Millikan-Lewis dispute. But as a linguist, it strikes me that there's another notion of convention, which I think is orthogonal, but I'm interested in whether you think it is. And it's the natural notion that you might think of in terms of processes of grammaticization or language change, where something emerges, or for that matter, disappears over time, some convention. And it could be a very high, in your terms, very high information convention, or a relatively low information convention that emerges and disappears in principle. And I'm wondering what you have to say about that. So is that simply a different use of the term conventional or degree of conventionality? Or is there a way of thinking about, if you like, the distribution of speech acts over time as itself representing something about the degree of conventionality that's kind of independent of the sort of a priori probability of an act? So the way you present things, it's kind of in terms of the a priori probability and no utility, but just probability. But it seems that if talking about behaviors evolving over time, we shouldn't be looking just at a priori conventions. So that was perhaps a little bit of a confused mixture, but you can see at least that there are 2 different notions, and I'm just trying of conventionality, and I'm looking for help in disentangling them, or looking forward to hearing that they're actually the same thing.
So I think there's sort of 2 things that are coming up here. So one is this notion of like, are we looking at a priori probabilities or something more real, something more that has emerged? And in that case, I think you really can look at either, because you can look at the stuff that's actually come out in a culture and say, well, that represents probabilities in some way, or you can look at a model that maybe starts from some neutral starting place and then gives you some a priori idea. And then the other thing, which I think is slightly different, is this idea of things changing over time. And, you know, in cultural evolutionary modeling, the way people often set it up is like you start from nowhere and then you end up at a stable equilibrium. But of course, that's only a representation of cultures in a very simplified way. Every culture starts from somewhere and goes to somewhere else. And that somewhere else is only partially stable. It's going to go to somewhere else eventually, right? In fact, cultures are constantly changing on these kind of paths. There is a way to think about conventions and their probabilities, even given this more dynamical picture, which is that you can also ask, like, how surprised am I to learn that a culture is engaging in some particular convention at any one time? So you can get probabilities that sort of track changes and flux over time. And so I can look at a culture at a time slice and say, well, right now they're doing this thing grammatically, maybe, or I'm not a linguist, but like their T's have shifted to D's or whatever. They don't have V's anymore right now. And then you can ask, given what we know about cultures and the way language works, how likely is that to be the case at some time? And then use that to sort of track the arbitrariness of that sort of convention. Is that responsive?
Yes, it is. I mean, I think I can put things in non-language terms too. I mean, if we just think about which side of the road we're driving, right now, if you just look at the distribution in the US, you find that actually it's really unsurprising for someone to be driving on the right-hand side of the road. Yeah. There's no information. So you might say, well, that's obviously not a convention by your measure, because like everyone's doing it, except for David. He drives on the wrong side. He obviously hasn't adapted very well to the local culture. He's got a convention, but everyone else, they don't have a convention. Only David. He's the only one with a driving convention. That seems intuitively wrong.
Mm-hmm. Yeah. So I think in that sort of case, so number one, if you're thinking about what one individual person is doing, that's not the sort of right level of representation, right? You want to be thinking of like, what's the cultural pattern within a culture? But
this was just a way of putting my question in mathematical terms. I wasn't seriously suggesting that I had a convention. I'm just looking, when you take mathematics and apply it, what produces the right notion of how conventional something is? Because superficially, if you look at driving in the US, it appears, if you just take that population as your sample, it suddenly appears by your measure non-conventional, which is the wrong result. Of course, if you take a different population, like driving across the world, it would turn out to be slightly more conventional, but still that doesn't seem quite right.
Well, so again, I think there are sort of two things here. So one is that, you know, sort of picking any representation, it's like you can, whenever you're modeling, whenever you're producing data to represent anything, basically anything you're doing in science, you have to pick good ways to build models and you have to pick good ways to gather your data. Because if you don't, you're just going to end up in a scenario that's not particularly illuminating and doesn't tell you much. So you can't just pick some really terrible representation and put it in here and get any sort of level of conventionality that will tell you anything, right? So there's that. But I think there's another point that we can make. So if let's analogize, instead of talking about one person as society, let's say that every society in the world was influenced by some society, and everyone happens to have the same basic word order, but it's not like they couldn't have had another one in principle. It's because of this historical constraint that you see this regularity. So that's a case where you might look at the data set and say, well, it looks like there's no conventionality here because it's all the same across all of society. But in reality, you might want to say there's an underlying scenario that could have some significant level of conventionality because it didn't have to be this way in some greater counterfactual. So if you're thinking about that scenario, then the right representation for you is something more like a model that tracks maybe payoffs to people for using different languages rather than the data set, because, you know, the data set is shaped by this historical, you know, constraint. And so it's not really representing the thing that you want. The thing that you want is to track, absent this historical context, how much conventionality we might have. So that's what I mean when I say you have to pick a representation that works for your explanatory project. So if your explanatory project is to think absent context, how much conventionality do we have here? you probably need a model rather than this very contingent data. If your project is to say, for all the countries in Europe that stemmed from Indo-European languages, how often do they end up with some particular function? Then you're giving a kind of more constrained picture there, right? You're picking a particular starting point, and then your representation takes that into account. Yeah, okay, that's it.
Thank you.
Okay, we have a question from Andy Finette.
Yes, can you hear me?
Yes.
Okay. Hello. Thank you, Cailin, for your presentation. Yeah, I really like the intuition. It seems, it seems okay to assume that something which has probability of 0.5 is totally arbitrary. And in fact, when you have probability 0.5, you also have maximum entropy. But the case where entropy is 0 occurs at least 2 times, when probability is 0 or probability is 1, something which is absolutely sure never to happen, or something which is absolutely sure to happen. So this is a point with regards to what you said, that is there's only one case where H is equal to 0, where the entropy, the Shannon index is equal to 0. So no, it's not true. You have at least 2 cases. And you have another problem. Let's say when you have values, probability values, close to 0 and close to 1, let's say 0.1 or 0.9. The value from 0.9, the probability of 0.9 to 1, you have an infinite number of possibilities, 0.91, 0.911, 0.9, etc., etc. So how would you categorize arbitrariness in this case? Because you are not arbitrary. In fact, probability of 0.9, very likely to happen, not arbitrary at all. So you have an infinite number of cases, in those, between those 2 extremes, from probability 0.9, let's say, to I don't know if you can visualize what I'm saying.
I think I understand. So with respect to this first point about 0 and 1, it seems like you are assuming we have a case where there's only 2 possible conventions. And so it means if one is definitely not going to emerge, there's another one that's totally certain to emerge. But that's going to be a very small number of cases where there's really only 2 cultural outcomes. I mean, the driving case is sort of special because, there's right and left, and the way roads work and cars work means that's all we've got. But in most cases, there's going to be more. And so really the only case where you won't have any conventionality is when there's one thing that's definitely going to emerge. Now, I think what you were talking about with the second is like, well, there could be scenarios where we maybe have some higher level uncertainty about the probabilities, where maybe it's 0.9 and 0.1, but maybe it's 0.91 and so you could imagine that there could be many cases and we're sort of not sure about it. In a case like that, if you want, you can build a model that builds in your uncertainty about the probabilities that different equilibria emerge. And so then you kind of have a meta model that captures all that uncertainty and yields some probabilities for different equilibria, given that you don't actually know what the real probabilities are. So you can, take different sorts of uncertainty over your models into account if you'd like to. I mean, if that makes sense for whatever project you're developing. Is that what you were talking about in that second case?
No.
Okay.
You're categorizing conventionality by the degree of arbitrariness. You are measuring the degree of arbitrariness by Shannon's entropy. Now, when you have values to put to construct the index, let's say if you have probability values, if you have values from, let's say, a value of 0.8, a probability of 0.8, a probability of 0.9, something like this, you would have a very low Shannon. And so by your interpretation of your index, you will say, okay, this case is not conventional. you see, you have an infinite number of possibilities where you would have to categorize things as unconventional because of the way that you interpret your index.
But I wouldn't want to categorize any of those as unconventional. They would just be somewhere on this scale of conventionality, and you could, you know, give a kind of number telling you how arbitrary they are based on whatever the actual values are.
I'm not sure that I got your answer, I got your point, because what are you plugging exactly into your index?
So
Just
whatever,
as an example.
what goes in are the sort of probabilities that different equilibria emerge. So in the example I gave, you know, there's 2 equilibria and maybe they're equally likely to emerge, or maybe one emerges much more than another. But you could also have a model where maybe there's 4 equilibria and one emerges 90% of the time, and the rest, you know, each emerge 3.3% of the time. And you could plug sort of any, you know, set of probabilities of emergence like that into the entropy equation and get this measure.
Okay, okay. Final observation. The thing which is very interesting with Shannon's entropy is that I have in mind the bell-shaped curve of of entropy when you plot probabilities with respect to probability against the H, Shannon's index. So how do you consider, how do you treat, two different, let's say you have your inputs and your output will have the same value because it is symmetric. It is bell-shaped, so you have a maximum point where the entropy is maximum, and it is symmetric.
Again, when you're just thinking of 2 possible outcomes. Yeah.
Yeah, which gives the same, exactly, 2 possible outcomes, 2 different scenarios, which gives exactly the same entropy. How do you categorize?
That seems just fine. I mean, say we have 2 equilibria, let's call them A and B. If there's an 80% chance of getting A and a 20% B, then that's the same sort of level of arbitrariness as a 20% chance of A and an 80% chance of B. In both cases, you'd be in a scenario that's equally arbitrary, and where when you see what emerged, you learn the same amount.
Okay, thank you.
Sure, no problem.
And maybe we should move to other questions. If anyone else? If not, I have just in a way a clarificatory questions and in relation to the distinction between conventions on the one hand and social norms. I mean, you explain the distinction in the book, and like when we talk about like discriminatory, you talk about discriminatory conventions or ways of kind of splitting the resources and so on. So for me, I was more kind of tempted to think in terms of social norms, a bit like a la Bicari and so on. But I wonder if the sense in which you want to use them is exactly the concept that you have today of convention. So just that's terminological issue, and then I will ask another question if there's no one else. But yeah, I see Kevin.
Yeah, I mean, so many people have done like great work on social norms and conventions and the relation between them, and are conventions always norms or not? And I sort of have like, stepped back and said, well, I won't like have some really strong view on this. Yeah, of course, for people who are like less familiar with this, norms are always considered, they don't always have to be conventions, because there can be norms that nobody actually fulfills. They aren't patterns of behavior, but they're, sort of things that have a should on them, like you ought to do this, you ought not to do that. Whereas conventions, I tend to think, and many people also tend to think, don't necessarily have a should. Sometimes there can be patterns of behavior you're fulfilling that lead to coordination that are fairly stable, but where even you might normatively say you should not do it. So like a stupid little example is that like when my kids were little, my husband and I were always so busy, and like at the end of the day we would sit down and always watch The Office together, but it would always be the case that there'd be 50 student emails that should be answered and reviewing that should be done and this and that. And so there was some sense in which we had a convention, but it definitely was not a norm. And if either of us broke it, we'd be like, yeah, you really should be helping your students advance instead of watching TV. So yeah, that's just a little kind of thought on that.
Sense that indeed when a convention is kind of entrenched, yeah, it's true that they can be, yeah, one-off thing, kind of just as it were defined to a particular defined, yeah, limited setting. But it is, to my mind at least, the way I'm thinking about norms is that you can kind of either have people adhering or then stop complying with the norm, and that kind of explains the shift. And you know that they're at one point in their life they're kind of you know, strong and flourishing, and other time they kind of start dying. And so that was the kind of the reason why I'm sort of wondering whether norms would involve sort of approval, disapproval, people following the norm or not. Whereas I kind of tend to think about conventions more like, yeah, in terms of when a meaning is conventionalized. And that kind of brings me to the other question where I was thinking like how, for instance, you know, a slurring word emerges, you know, that convention starts emerging in a given group or population, then it spreads, and then you might think that certain of those words then they will lose, you know, diachronically they will lose their force, as it were, that they had at the beginning. Have any thoughts on that?
I don't know. I mean, so as I've sort of flagged, like semantic meaning is something I haven't thought a lot about with this account because it's so hard like to model actual linguistic cases in a realistic way. And especially this kind of thing you're thinking about where there are meanings that have this kind of thicker psychological content associated with terms, and those thick concepts change over time. I mean, I think that'd be like fairly hard to capture and model in a framework like this. I mean, you've thought more about that, I think, than I have.
The way to go, would it be a matter of like how the entropy evolves, like whether it kind of it's going to zero or it's going to infinity? Would that be a way of kind of capturing when the convention is losing its you know, its force, as opposed to being
no, so that wouldn't track the sort of case that you're thinking about on the framework that I've been building, because this, what I'm really thinking about here are these cases where there are sort of multiple options that could come about, and you're thinking about, well, like how could they really have been other options? Whereas I think you're thinking more about how the sort of content or meaning of one convention is changing over time, which I think is a different scenario.
Okay. So I see a finger from David and a question from Kevin.
Just a quick comment on the difficulty of finding probability estimates. There are a lot of people that spend time doing that on the psycholinguistic side. There are people that investigate constant rate of information theories of processing, and they need to use estimate probabilities, which they might do based on frequencies or based on more complicated language models. In computational linguistic theories of semantics and computational semantics, people approximate meanings in terms of kind of collocational vectors and in other ways, and they build more. They've got probabilities coming out of the wazoo. It's like all over the place, and very interesting distributional. I mean, it's called distributional semantics. Very interesting results. So I wouldn't. The comment is just, although it's not clear what one should think about these as models of meaning, it's nonetheless the case that very many people are extracting the sorts of measures you're looking at for things that at least correlate with meaning. So it's not out of the question to look in that direction.
That's really interesting. Yeah. And I mean, like, as I said, I'm not a linguist, but I have talked to a number of linguists sort of informally while doing this project, and the sort of examples I kept pulling out, I mean, it turns out there's a lot of things in language that this framework actually is quite useful to think about. Things like word order, where you have some set number of constrained possibilities that come out, or like another one I talk about is color categorization, where you can look cross-culturally and see that if you look at the basic color terms in a language, languages have between 2 and 11. So, and there's a kind of distribution in how likely you are to have very few or very many basic color terms. And so that's another case where you can kind of think about this sort of constrained process of the emergence of some kind of linguistic features. Or, I talk in the paper about the example that Kevin and Mandy were interested in, having to do with whether implicature is entirely inferential or partially conventional. And, they sort of build a model where you would have, now I can't remember the details of how you call it, but like, oh God, didn't even write this that long ago. But you would have sort of either implicature or non-implicature as part of your language. And like, that's another place where you can like have a kind of constrained representation of what might happen or not happen. So there actually have been a lot of things in language where the framework does work, but the main thing that I hadn't found much success with was just like semantic meaning, which
the color one
sounds mean something.
The color one is an interesting example because Gerhard Jaeger did some simulational work, but based on kind of raw data extracted from languages. So he's looking at stable patterns of kind of color reference terms. So that's interesting, partly because it connects to this I mentioned historical issues in my earlier question. So it relates to that. In simulational work on meaning change, you'll be able in artificial settings to look at directly at probabilities and look at whether your interpretation of conventionality seems intuitively appropriate and whether it's useful in describing what's going on. So there's a lot of work there to connect to. But I'm sorry, I meant that to be a
that's actually, it's very on the nose. So I wrote my dissertation on the kind of signaling model that Jaeger, uses to represent cases like color categorization, like the Synmax game. And so, yeah, it's not accidental that was one of the examples I'm looking at.
So I see also a note from Christoph on colors, but insofar as we can go into the discussion. So Kevin had a question prior to that, and then Christoph can come back.
Oh yeah, so it was, I think it was just to maybe, I don't know, emphasize something that you already said, or maybe just to ask you to say a little bit more about it in particular, because I think that it strikes me that one of the things that we sometimes want to say about conventions, and that you say like in your book quite a bit, is about how like previous conventions can impact the likelihood of future conventions, right? So like if men are traditionally in charge of maintaining the electrical system in a household, then when wireless internet comes around, it's very likely that they then will take care of that too, because it's electrical or something like that, right? And so it strikes me, I guess I was wondering, do you think that this is an approach that would allow us to actually say something really concrete about that, where we could compare in some backgrounds or not backgrounds about the relative conventionality of something? So you would say, like, in a society where men take care of the electrical appliances, it's not conventional that they would take care of the wireless internet router. But in a society where the division of labor of electrical devices is approximately equal, then it is conventional. Do you think that that's something that one can say here by, say, comparing different antecedent states or different models, or are you worried that comparing across models, I mean, is there a landmine there, when you're trying to compare across conventionality across different models or something?
No, I actually think that's a very like useful and natural application of this way of talking, right? Like we can talk about different cultures, the sort of constraints they're under, and then how likely different outcomes are in those different cultures. And it, you know, maybe it's a little weird to say in this culture it's more conventional and in that more arbitrary and that one less arbitrary. But that's actually not that weird to say. I think actually there's a really good example of this that I discuss in the book having to do with gender division of labor and then later like gendered inequity, which is if you look at cultures, and this is from work by economists, where plow-based agriculture was the standard, later on they tend to have greater gender inequity. And the reason is that, well, men tended to be in charge of major resources in plow-based agricultural societies because the food is making all the money, right? Whereas in hoe-based agricultural societies, later on you see greater gender equity for similar reasons, that more often women are in charge of like these resources and creating them. So that would be scenarios where you could have these different antecedents, and then you talk about the conventions later on, these bargaining conventions related to who gets more or less in different scenarios. And you could say in one case, it's pushing you, you know, towards more or less kind of arbitrariness there. So I think that makes total sense.
You have a note on colors?
I was just wondering about colors and cultural evolution, right? That's an interesting case, right? So let's say the ancients didn't have a word for blue. You probably know this better than I do, but because a lot of shades of blue they would group with black, right? So presumably people thousands of years ago perceived the same colors that we do. So they have the same color space. And then what's evolving culturally is the partitioning of that space, right? And if you're taking Shannon Entropy to sort of distinguish these mutually exclusive alternatives, these A, B, C's, D's, and so forth, right? Greeks not being able to sort of put a label on blue because for them that's kind of a black. It's like what's culturally evolving is that the space is being repartitioned into having different kinds of options. So I don't know. I'm just wondering, like, how would you bring cultural evolution together with a repartitioning of whatever?
Yeah, this is
space concept you have.
Exactly right, and exactly how what this example tracks is that, you know, you have these different scenarios where different cultures, you know, there's multiple things feeding into it. You have perceptual spaces that are presumably fairly similar across different humans. You have coordination needs where some cultures have use for more color terms or specific types of color terms. You know, so, like certain colors are more relevant to some cultures based on their other patterns of behavior. And then you have these processes by which terms emerge that partition these spaces. And there's a lot of debate about how much constraint there is on the way those partitions emerge and what is leading to the patterns you see. So some people think there's a lot of regularity in these partitions and it's driven by salient colors in color space, and other people argue no, it entirely has to do with coordination needs and conventionality and sort of arbitrariness from you know, sort of past interactions, you know, that there's quite a lot of arbitrariness there. And so this is why this was such an interesting case to me, because there are these debates really about the level of arbitrariness that you see when you're looking at these color categories. Are they highly arbitrary? Or are they not that arbitrary? And so I thought this is kind of a case where if you wanted, you could apply, you know, you can look at different models and compare them to the actual data sets you see to think about, like, you know, what is the underlying level of arbitrariness? What is the level of arbitrariness you actually see in the data set? Where does that come from? It's, yeah, but it, like color scientists, this is like a big, angry debate, actually.
I know. I'm just wondering if something like the color space is categorically different from like some of those grammatical distinctions you mentioned, right? Like grammatical things that evolve over thousands of years. It's like you add a new combinatorial option to a language, and then that exists. That's like adding a new variable A, B, C, and so forth, and bringing that into existence. Whereas with the color space is fixed. Like the colors that the human eye can perceive is fixed. So when the partitioning changes, I'm just wondering if you want to make distinctions. So if you have these different examples, I'm just wondering if something like the color space, because it's finite for the human eye, is categorically different from other examples where you can as cultural artifacts, you can add new stuff to it, and then you're extending the space. And that qualitatively seems different to me than something that is always fixed and completely independent of human evolution.
Well, I think there are, there's many different sorts of cases you can look at, and there are many different levels of how constrained the evolution is, like how many options there are going to be. Could there be an indefinite number? Could there be really a lot of them? In the color case, the perceptual space is fixed, but the number of terms is not fixed, and the way you partition them is not fixed, and all of that changes a lot. In the driving case, there's really two options. It's a weird case where there just really are two. With word order, really there's 6 for the most part. So I don't think of them as like there being classes of cases here, but a great variety of many different sorts of scenarios you can be in as far as the evolution of conventionality goes, and how many options or constraints there are on that.
Well, great creativity could always add like new options, like the sign in the park that says "Don't walk on the grass." Like with the road example, you can drive on the left side and the right side, but then some people think outside the box and they do something that no one thinks about. Like I saw this one sign with like a national park, and it says like "Don't throw coins in the fountain" or something, or in a pool of water, because people used to do that. So someone was just like being funny and said like, what if I take money, right? Because the sign is there to prevent people from stepping into the pool of water because it's a nature reserve. And people think outside the box all the time. So it's like, you can always kind of have a finite, like you said, like with the perceptual example, the real world space is finite, and the perception of it, we invent new categories for it. But I'm just wondering if we have a need for some kind of general approach to how we deal with the difference between what the physical space is and what the conceptual space is that maps onto it. See what I'm saying?
I mean, in the particular case, you certainly want an approach that lets you think about that, but I don't think it makes that a very like some particular or unique case for cultural evolution. I mean, in almost every case, there are facts about the human body, facts about the physical world around us, facts about the way people socially interact with each other, and all of these different kind of physical type constraints, shape what things can emerge or make sense or, would be likely to emerge. And so I think, yeah, I don't see it as being like a very clearly different sort of case.
But you see what I mean? Like if the creativity is very high,
creativity, I mean,
then the Shannon entropy
is like, yeah, in cases like, so fashion came up earlier that Jose brought that up. That's a case where it's very hard to model because you could keep adding more possibilities, right? You can always come up with some new fashion. Like you can make a pointy hat that goes up 10 feet instead of 4 feet. Hopefully not that, but yeah, so there are cases like that where there are almost indefinite options because of creativity. I mean, even the road case, I'm like, there's right and left, but maybe we invent hover cars and then the whole scenario will be different anyway.
Yeah.
All right. I don't see any further questions unless I'm missing something. But I mean, we can transition into the round table, so we can talk about more general questions. So I'll stop the recording here.